Okay, in this problem, I've got a 1438 column A36 steel. Okay, it's fixed at the base, free at the top. Okay, subjected to 15 kips, and I want to find the factor of safety on this guy. So the first thing I'm going to do is figure out what my critical load is, and then use my actual load to figure out the factor of safety. So again, my critical load equation is going to be pi squared. Oops. Pi squared EI over KL squared. Okay, so we'll go ahead and go through this. So again, we've got pi squared. E, this is A36 steel. We can look that up. It is 29 times 10 to the 6 psi. Okay, again, get that from the back of the book. Now, we're going to go to Appendix B, okay, and you're going to want to remember that this guy is going to buckle on the weak axis. So I have, two I's that I can look up depending on which way it buckles. So one I is 385 inches to the fourth, and the other I is 26.7 e to the fourth when I look up the moment of inertia for that specific beam in the back of the book in Appendix B. And again, I want to use the smaller one. The smaller one is the one it's going to buckle about, right? That's the weak axis. That's the one I want to use because I want to design for worst case scenario. So I use the weakest axis, which is 26.7, not the 385. Okay. Once I have that, then go down here. Fixed free gives me a K value of 2. Okay, so it has an effective length of twice of what a pinned is. Okay, so it's going to be 2, and instead of 20 feet, I'm going to use 240 inches. I want everything in inches. Okay, because I've got psi. I also have inches to the fourth on I. So instead of 20 feet, I need 240 inches. That whole value squared. Okay, so again, you look up E. You use the weak I, right? The weakest moment of inertia, and then an effective length of 2, making sure that you use inches on everything. From that, I get an effective load. A critical load, 33.17 kips. Okay. Now, to find the factor of safety, I just very simply divide the two, which is going to be 33.17. I'm only putting 15 on this sucker, so this guy has a factor of safety of 2.21. Okay, so again, just use what we know using our critical load equation to calculate the critical load, and then just divide it by what I'm actually putting on it to find the factor of safety.